So we're going to talk briefly about naming things using what's called the stock system. The stock system is bigger than what we're going to do here. There's more to it than this. We'll dabble in it a little bit. It's really a whole other system for naming chemical compounds. Where it comes into play for us for ionic compounds is with metals, because in the transition metals, you know that a lot of those can make multiple ions. And I just gave you a reference sheet. So up here you have a handy-dandy little table that helps you remember which groups make what ions, and that's nice. And it also, tells you the aluminum and nitride ions, +3, -3, which is nice. The next section right here, that's mislabeled. That label should be down here, and this label should be up here. I don't know how that happened, but I fixed it last night because I noticed it last night, but I forgot I had printed these before I fixed it. So, what we have in this first section are actually the common ions made from the D block. So these are metals that commonly make various ions. So you can see, like copper commonly makes copper 1 ion or a copper 2 ion. Iron commonly makes iron 2, iron 3. There are some higher cations of iron. These aren't necessarily, it's not an exhaustive list, but these are the most common ones you're going to run across. I mean, chromium is listed on there. There's chromium, 2, 3, but there's also a chromium 6 ion that exists out in the world. It's nasty stuff, too. But, there are ions that are not listed here. Just because it's not on this list doesn't mean that it doesn't exist, but these are the really common ones. Now, because, when we say it's a sodium ion, you know immediately the charge is +1. Sodium ion +1, period. You know that right off the top of your head. I could wake you up at 2 in the morning, shake you awake. Kylie, what's the charge on a sodium ion? You go, +1? Why are you here? So you know that. But with copper, when we say it's a copper ion, we don't know if it's copper 1 or copper 2, so we have to name it. So every time that we talk about one of these transition metal ions, we have to name it. The copper 1 ion is Cu1+. Copper 2 ion is Cu2+. Well, that's great, but it dictates the ratios that these things are going to form when they form compounds. So copper 1 ions plus oxygen form Cu2O. That is called, so you're pretty good now at naming binary ionic compounds. What would that be called? Copper oxide, except we have to name it for the ion that's involved. And the name of that copper ion is what? Copper 1. That is copper 1 oxide. That is copper 1 oxide. And I heard a bunch of you say copper 2, because that's the easy mistake to make. You look at that subscript and you go, oh yeah, there's a 2 there. That subscript isn't the name of the ion. Ionic compounds are named using the first name and last name, name of the ion, name of the ion. So you have to figure out which ion of copper you're dealing with, and the subscript is not the charge. So this is copper 1 oxide. Well, what if I had, shrink that up. What if I had a compound made out of copper 2 ions, Cu2+, and oxygen, O2-. I get Cu2O2. What does it simplify to? CuO. What's this one called? This is copper 2 oxide, because it's named for the ion. Okay? That part's pretty easy. Do you want to show me the parts? Do you want me to show you the parts where it gets tough? Because this is easy. If I tell you, hey, I've got something with copper 2 ions and this other kind of ion, you know how to write a copper 2 ion. If I tell you it's a copper 2 ion, you know it has a +2 charge. Great. So when the going gets hairy is when we do things like this. And I say to you, what is this compound called? So, when you're naming an ionic compound, you know that it's name of the first ion, name of the second ion. We know this is going to be iron oxide, but if we just say it's iron oxide, we're wrong, because it's iron some number oxide, and we don't know what that number is yet. So to find the charge on the iron, you have to actually do a reverse crisscross. So remember when we're writing binary ionic formulas, we put the ions up here, and then we crisscross our charges and we get our subscripts. We can do the same thing in reverse. So now we know that this was iron what? This is iron 3 oxide. And we have to look at that oxygen. Is oxygen normally 2 minus? Yes. So we know this is right. There wasn't any simplification involved. So this is iron 3 oxide. I call it the reverse crisscross. You can call it whatever you want. You can call it, you know, monkey in a barrel. I don't care what you call it, but it works. SNO. Do you know what SN is? Tin! Do you know the mnemonic for that? Tin snips. Snips. SN. Tin snips. It is. It will. So, you've got tin oxide, but we don't know which ion of tin. So we know that this is tin something oxide. So, as usual, we're going to do the reverse crisscross on this. We know that tin would be the positive ion, oxygen would be the anion. So we have SNO, which means it's a 1 in each place. 1 and 1. So this is tin 1 oxide? No, because oxygen doesn't form a 1 minus ion. Oxygen always forms a 2 minus ion. So this must have been simplified. Well, what do we have to multiply this charge on oxygen by to get oxygen's normal charge? 2. Which means this was simplified, which means we have what? Tin 2 oxide. Does that make sense? You want to do one that's another tricky one together? We'll set this one apart. Okay. I give you PbO2. You know what Pb is? I don't want any lead in my peanut butter sandwich. It's lead. Some people remember that with plumbing. We have sometimes lead in plumbing. That might be helpful to you. Think about Flint, Michigan. They have lots of lead in their plumbing. Okay, so we're going to do the same thing we've been doing. Well, we know that this is lead something oxide. Lots of oxides. It's an oxide kind of day. So we know that this was lead with some one of those. We do our reverse crisscross. We get 2 and 1. Is this lead 2 oxide? Why not? Oxygen forms a 2 minus ion. So we have to multiply each of these by 2. Which oxide of lead is this? This is lead 4 oxide. Okay. These aren't hard, but the common places to make mistakes are just forgetting to specify that there's more than one ion of something. So forgetting to say that it's copper 1 or copper 2, just saying copper oxide. Or forgetting to unsimplify something that's been simplified. So, you should be pretty aware of the common, chlorides and oxides. You know what charge those have. So you have the practice sheet for stock system. If you already did it and you already did the FIP quiz, you get a little bit of breathing room, I guess. You're welcome to start on the polyatomics. I have a video for those, and there's a practice sheet. I don't have the FIP up for that yet. I wanted to wait until a few more people had the stock FIP. Who's done with the stock practice? Okay.